This assignment is all about the different research methods you can use to collect which data depending on the type of research design. Before you conduct any experiment, you will have to consider what type of research will be most appropriate to answer your research question. This will either be quantitative or qualitative. Research methods include the types of study used in any investigation where each method uses certain techniques to handle the research. For example, qualitative methods include focus groups, observations, interviews, and questionnaires, and quantitative includes experiments, observations, and questionnaires. Whereas research design is a specific framework for your research, it explains how you will use the method you selected for your research. This is also where you note your variables that would be apparent in the experiment. It is important to use a research design because we rely on this to get the evidence to answer the research problem and therefore obtain more valid and reliable information. For choosing the right research design, you have to work out whether your experiment is analysing data numerically, in which case you would use qualitative methods, or purely descriptive, where this would be quantitative methods. In order to gain data, you will need to identify firstly the topic or area you are researching, so what information do you need? Next, you have to see what the intention is of the experiment and therefore what structure you'll be using. Finally, you can then choose what type of study will help you get this data. For quantitative data, case studies, cross-sectional, longitudinal, and correlational designs can be used, whereas for quantitative data, you can use experimental, cross-sectional, and longitudinal. There are 5 different research designs in total. These are experimental, correlational, cross-sectional, case studies, comparative, and longitudinal. Experimental designs should be carried out in controlled conditions where the researcher can manipulate the variables to see if the independent variable has an effect on the dependent variable. A sporting example would be where a gymnastics coach wants to see if a gymnast's lower body flexibility is benefiting her floor performances. Flexibility would be the independent variable and performance is the dependent variable. Correlational research is quantitative data which is non-experimental and is used to identify relationships between variables and how one variable affects the other. A simple example would be seeing if the muscular endurance of a gymnast would affect the time period they can perform for. Correlation is an R value and is calculated using a statistical test and is between -1 and positive +1, where you can determine the strength and direction of the correlation. Data can be plotted on a scatter graph to determine this. Another simple example would be seeing if the thigh girth affected the height at which gymnasts were able to jump during trampolining. Cross-sectional is a type of observational study that analyses data collected from a population from a single or specific point in time. It allows you to make comparisons from different periods of times but largely depends on the sample sizes because this needs to be big enough as it is a representative of what you're trying to find. It is simply a mini profile of an athlete. An example would include taking a sample from 13-year-old female gymnasts and choosing a particular component of fitness, such as power, and measuring this throughout each event, such as beam, vault, bar, and floor work at a particular point in time. You could then do this for the entire fitness components to create your profile. Case studies are where you investigate a particular individual or team over a long period of time. It takes into account the development of the area that you are investigating over time and the environment in which the research is taking place. In a sporting context, this would be if you were to investigate the psychological effects of injury at different stages of injury and recovery for a GB British gymnast. This allows you to investigate one person at different periods throughout their stages of injury and means you can draw conclusions relating to that individual and suggest these conclusions as directions for future research on a larger scale. Comparative is where 2 or more subjects with similar characteristics are compared to measure what characteristics separate them in ability. It is to see any underlying structures which generate these variations. You can compare individuals, countries, or cultures, and it can either be quantitative or qualitative. An example would be choosing 2 gymnasts who have similar height, weight, or age, and comparing them to each other to see which one has the better ability and why this would be so. Longitudinal studies are a type of correlational research which involves looking at variables over an extended period of time, such as weeks, months, or even years. This is used to discover relationships between variables and again, like cross-sectional, it obtains data from a single point in time, so it is an ongoing snapshot of an athlete. There is no manipulation, just pure observation. In a sporting context, this would be looking at the effects of how steroids affect the body composition of a gymnast over 10 years. You would collect data on how the participant's performance has changed and then re-evaluate the athlete every year. Once you've decided the appropriate design for your experiment, the researcher must then plan the detailed research method and how they're going to collect the data. There are 2 types of research. The first is primary research. This is where you collect data as the researcher through interviews, questionnaires, and observations. With primary, as it is your own experiment, you have direct control with variables, making sure they are not manipulated, or if they are, at the points you want them to be, so you can ensure it's mostly going to be accurate. Due to the fact it's your experiment as well, and you're putting the effort into finding the certain data, it is more valuable and rewarding. However, it will be expensive and does take a lot of time, as you need to find a suitable setting to carry the research out, and finding all the equipment that you need and potential training on the equipment, if it is a lab experiment, will cost. There is also a potential of participant bias as well, because you may not be looking for participants that have certain characteristics to keep it as accurate. Most researchers will generally take participants who are readily available. An example of primary research is where a researcher would look to see if there was a correlation between the lower body flexibility and scores on floor work performance. He or she would conduct this experiment themselves and get data themselves. Secondary data is where you use other accredited sources' published data. This can be found in books, journals, websites, and other forms of media which are easily accessible. Furthermore, it is used to support or counter-argue your own research findings that allows comparisons to be made. An advantage to a secondary researcher is it's cheap, because you don't have to spend money on equipment or resources, and you don't have to go through the effort and process of conducting the research yourselves. However, because it has come from another source, there could be reliability issues such as the date. If the research was conducted 60 years ago, there is likely to be some accuracy issues because technologies have been improved since, compared to another data source which was published 10 years ago. This is a lot newer. Also, the quality might be at a disadvantage, as this experiment may not have been carried out correctly, or may not have followed the right procedures to ensure it's a fair test. If the primary researcher found out there was a positive correlation between lower body flexibility and floor work performance, they might want to get additional evidence to support their hypothesis. In this case, they might find in a book in a library another researcher conducted a similar experiment and found similar results, which would support the primary researcher's results, so they are able to accept the theory. Within research, we can classify data into different levels. These are discrete, ordinal, nominal, continuous ratio, or continuous interval. Knowing the type of data you're working with and knowing which classification it is under will enable you to identify which statistical test to use. For example, using the paired t-test for nominal data. The highest level of measurement is ratio data, and each data classification will provide different detail of data. Discrete data is a form of data where only separate, isolated, or opposite values can be achieved. For example, male or female, win or lose, yes or no. In a sporting context, this would be asking the question, do you like trampolining, with a yes or no answer outcome. Nominal data is where participants are put into categories where a tally is used to get frequency data. For example, what is your favourite event in gymnastics? You can place gymnasts in categories based on their choice of answers. These categories could be the bar, floor work, beam, or the vault. Ordinal data is ranked data that gives no indication of the difference between levels. It allows you to say who was fastest or slowest, first or second, but does not tell you the difference between values. So this just gives a rank order but not an exact value. For example, the different ranks and flexibility among the 13-year-old gymnasts. Continuous data is data that can have any numerical value with any number of decimal places. We have two types and can either be ratio or interval. Interval is based on a scale that has equal intervals of measurement between each score, and these can be negative or positive values. For example, measuring the body temperature of the gymnast against the intensity of the training. Ratio data has proportional equal units of measurement and has a scale range from 0 upwards, so cannot have negative scores. This type of data is used to measure physical measurements such as heart rate, height, weight, thigh girth, etc. For example, measuring how caffeine affects heart rate on performance, or measuring thigh girth, how thigh girth affects the vertical jump height in trampolining.